Hello everyone, welcome to the channel of Algocamp. So now on this particular channel, we are actually releasing a series on data structures and algorithms where we are going to talk about some of the most important data structures and algorithmic topics which are extremely important for your upcoming software engineering interviews. Apart from that, these are some of the I would say topics that are very helpful in your day-to-day engineering job as well. We have already released a couple of series around searching, right? And we got a really good response on that. And from here, we are going to put really some awesome content around DSA. In most of these lectures, we will try to ensure that we focus on the intuition building aspect of the things, that how you are able to think about something, what are some of the things that people actually neglect but are going to clear some of the really important fundamentals. We are going to see coding implementation, but trust me, my focus is not going to be on the language delivery aspect of the things, that okay, you have to code this in C++ or Java. A lot of problems we have coded in multiple languages. Maybe some of the problems will be in C++, some will be only in JavaScript. I believe if you are somebody who is preparing for an interview, language in 2025 should not be a constraint, because most of the people can actually use ChatGPT to do language conversions. So my motive here is to make sure that you understand the concept in depth. You actually see how exactly somebody might have thought about the problem when they were carving out the problem, what can be some initial thought process, how you can actually drive yourself towards the solution. I believe these are going to be some really important videos that will be really helpful for your upcoming career. So do let us know what is your feedback. We are going to release a lot of more topics. Do let us know what all topics you want to have first, right? And the feedback is going to be important. Also, in case you are actually thinking to level up, you want to learn things with respect to low-level design, high-level design, overall system design for interviews, or you are somebody who wants to do project development in Spring Boot, you want to learn advanced Spring Boot concepts, or let's say advanced Node.js concepts, then we have a lot of courses, live courses running on algocamp.io. So you can check out the website courses.algocamp.io/learn, and there are a lot of courses that are actually listed. A lot of great discounts are actually going on all the courses as well. Do check them out. For each and every single course, we are going to add you to a dedicated Discord community where you can get your doubts resolved as well. All of the courses, we have made sure that we talk about things from the very beginner to the very advanced level that is going to help you level up in your career as a software engineer. So that being said, let's start the video without any further delay. So this is a new problem in front of us. The problem says that given a string of alphabets, right? So you'll be having a string of all alphabet characters. Print all possible subsequences of the given string. The ordering doesn't matter. Now you might be thinking, what is a subsequence? Okay. So let me first of all explain what is a subsequence. Right. So all of you might have heard about subsets, right? So if I write a set like 1, 2, 3, what is a set? Set is a collection of items, right? Let's say this is the given set. And what is a set? Collection of items, right? So for a given set, there exist multiple subsets of it. What is a subset? These are the subset. One subset is 1, 2. One subset is 2, 3. One subset is 1, 3. One subset is 1, 2, 3 itself. One is just 1, just 2, just 3. And the last is empty. Okay. So these are the subsets of a given set. Now what is a subset? Let me explain. Subset first, and based on that we'll be able to get subsequences. Now what is a subset? So if you try to define subset of a given set, like one thing that you have to keep in mind, that subset always exists with respect to a set. Okay, subset always exists with respect to a set. So these are a subset is a collection of items that is derived from the set. So before we start this particular video, I wanted to actually talk about a very small thing. So this video is going to actually help you understand a real system design interview scenario. We are going to try to mimic a 45 to 60 minute kind of like a round where we are going to solve a problem very similar to how you will solve a similar system design problem in this short time frame. Now, of course, when you work as a software engineer in a company, you have relatively larger amount of time and you can do a lot of more deep dives in even very small level features. But in an interview, the temperament is different, the approach is different, and a similar scenario is actually explained in this particular video. So do consume the content based on that. Also, if you want to see more deep dives and want to understand these topics in a much more deeper level concepts, then do check out the link in the description section below for our System Design 2.0 cohort, where we have talked about a lot more concepts in a lot more detail, which will make you definitely a better software engineer. So let's just start the video. Such that you can pick some elements and you can avoid some elements. This is something that you have to keep in mind. For example, if you see the subset 1 comma 2, then in 1 comma 2 we picked 1 comma 2 and we didn't pick 3. We didn't pick 3, right? So we can say that if in simple terms we have to explain, then subset is any possible combination of the original set, any possible combination of elements of the original set, right? So whatever elements you are having in the original set, any combinations you pick, like you sometimes pick 1 3, that becomes a set of combination, that will be one subset. You picked all 3, that's one combination. You pick nothing, that's one combination. So in different ways you can pick elements, right? In different ways you can pick elements. So you can say that subset is nothing but all possible combinations of a given set of elements. This is the basic definition of subset, right? Now, what is a subsequence? Now, what is a subsequence? Once you know that subset is just any possible combinations of picking the elements from the given set, what is a subsequence? Now, the formal definition of subsequence is that it is a sequence of elements. It is a sequence of elements of the array, or I should say set for the time being. Let's not go in program of array. Let's say set. It is a sequence of element of set obtained by deletion of some elements of the set. By deletion of some elements of the set, right? So what I'm talking about here, what I'm actually talking about here, let's see. Now, if you just carefully understand this definition, it says that you can pick some elements and the final subsequence that we will be building will be built by deletion of some elements. Now just think about it. If you see 1 comma 3, here I have deleted 2. If you see 1 comma 2, here I have deleted 3, right? If you see 1, I have deleted 2 3. If you see 3, I have deleted 1 2. If you see 2, I have deleted 1 3. So technically subsequence looks similar to subset, right? Subsequence looks similar to subset. That technically this is how subset is also formed, right? If you delete all of them, you get empty. If you delete none of them, you get all. So there is a very slight difference. There is a very slight difference. Subsequence might sound similar to subset. Subsequence might sound similar to subset, but here relative ordering of elements matter. Okay. Now technically, if you are writing subset, then instead of 2 3, I can also write 3 2. This subset can be written as 3 2 also. 3 2 is a valid subset of 1 comma 2 comma 3. No problem at all. Instead of writing 2 comma 3, we can write it at 3 2. Why? Because subset is just some possible combinations, right? So 3 2 is also a possible combination. But subsequence is found by deletion of elements. So if you are deleting the elements, the ordering of the other elements remains as it is, right? That's why 2 comma 3 qualifies as a subsequence as well as a subset, but 3 comma 2 only qualifies as a subset, not as a subsequence. So if you want to get a basic definition in your mind regarding subsequences and subset, then you can say that subsets are any possible combinations, right? And in subset, ordering doesn't matter. Ordering doesn't matter. Right? Whereas in subsequence, ordering matters. And why ordering matters? Because actually, by definition, subsequence is formed by deletion of some elements. By deletion of some elements. By deletion of some elements. So if some elements are getting deleted, we don't touch any other element, right? We are not picking any other element, or we are not modifying any other element. We are just removing some elements. So the positions of other elements, other remaining elements, or other unaffected elements remains as it is. That's why, to understand it easily in my mind when I was learning programming, I just kept this rule of thumb that subsequence is everything about subset, with the only catch that in subsequence relative ordering of the elements also matter. And sometimes it can happen, that in the question, like sometimes when you will be solving algorithmic problems, then there also they will define subsequence or subset for your aid. Sometimes they might modify the definition of subsequence with their own, I would say, version of subsequence for their particular problem. So don't get confused. This is like a general definition of subsequence. 99% of the time, whenever you read subsequence, you need to understand this only. But for 1% of the case where people will try to modify the definition, then you can say that that is their version of subsequence. It's not the general subsequence. So the rule of thumb, in subsequence, you also do kind of like subsets. It's just that order definitely matters. In subset, order doesn't matter. So I can say every subsequence is a subset, but not every subset is a subsequence. We can say that. Okay. This is the basic definition around subsequence and subset. Now, a lot of times in the world of programming, you will be representing this set as an array. So you might be asked to calculate subset of an array or subsequence of an array, right? Sometimes it might be replaced with string. So you might be asked to calculate subsequence of a string, right? So in programming world, actually set has a different meaning. Like the word set has a different meaning. It's a different data structure. It's not just collection of some items. Here in programming, collection of items is just technically represented by arrays, right? So these are the two definitions, subsequences and subsets. Now there exists one more thing, sub array. What is sub array? These are contiguous cross section of the given array, right? They are different from subsequences, right? Now let's see what I'm trying to say. So if you have an array 1 2 3 4, and if I want to write subsequence of the array, just think about it. I'm talking about subsequence, okay? So can I say that 2 comma 4 is a valid subsequence of the given array? 1 comma 4 is also valid subsequence of a given array, right? So in subsequences are found by deleting some elements. So in subsequences, ordering matters, but continuity doesn't matter. Continuity doesn't matter, right? Continuity doesn't matter. In case of subarray, continuity is the main factor. They are always found by contiguous cross section. So if I write subarrays of the given array, we have 1 2, 3, 4. Now you might be thinking, okay, these are single elements. Of course, if you just have one single element, that's continuous. But apart from that, 1, 2, 2, 3, 3, 4. These are all 2 length subarrays. 1, 2, 2, 3, 3, 4. Then 1, 2, 3, 2, 3, 4. These are 3 length subarrays. 1, 2, 3, 2, 3, 4. And this is 1, 2, 3, 4. The whole array is also a subarray. So when you actually talk about subarrays, then they are actually referring to contiguous cross section, right? And if we are talking about continuous cross section, then it means that some subsequences are non-continuous, like 1, 3 is non-continuous, right? So 1, 3 is a subsequence, but it is not a subarray. But we can say every subarray exists as a subsequence. Like this is also a subsequence. 3, 4 is also a subsequence. So we can say that every subarray is a subsequence, but not all subsequence is a subarray. This is something that you have to keep in mind, right? So you can see the larger picture is subset. From subset, you have some subsequences. Then from some subsequences, you have some subarrays. And just to not get confused, in case of strings, you don't call it as subarrays, you call it as substrings. Okay. In case of strings, the same definition when exists with string, it is called as substrings. Okay. So subset, subarray, substring, subsequence. These are the 4 terms that you are going to hear like humongous number of times throughout your programming journey, right? And it becomes extremely important for us to keep a segregated mindset about these, that what is the difference between each one of them, right? So I hope the overall discussion around subset, subsequence, subarray, substring is clear to everyone. Now in this problem statement, we have been given a string of alphabets, right? You can see A, B, C. And you have to print all possible subsequences of the given string. Now we know the meaning of subsequences, right? Subsequences are subsets that maintain relative orders, or you can say the combination of elements formed by deletion of some other elements, right? So ordering doesn't matter. When I say ordering doesn't matter, then I mean that the final output of subsequences, it can be like you printed AB before ABC. This kind of ordering doesn't matter. Like this is also a valid output. So the ordering of the strings within themselves doesn't matter, right? But of course, in one string, the ordering of character do matter. So how can we kind of like print all possible subsequences? This is something that we have to think about, and we have to do this recursively. Now you can carefully see that this is coming from that printing strategy, right? Like we have to actually print the combinations that exist. So maybe our printing strategy that we discussed of keeping a output string kind of a thing might help here. Now, how can we get the subsequences? Let's think about it. If there is a string ABC, you can see the subsequences are ABC, AB, BC, AC, ABC, and a empty string as well. Now, of course, these are same as subsets, right? It's just that the ordering also matters. Now, in elementary classes, we might have heard about the fact that if there is a subset, if there is a set of n elements, the total number of subsets becomes 2 raised to the power n. The total number of subsets actually become 2 raised to the power n, right? Now, how exactly total number of subsets become 2 raised per n? For example, if you consider this as a set of character A, B, C, then 2 raised to the power 3 is what? 8. Total there should be 8 subsequences or 8 subset. For the timing we are considering subsequences. 1, 2, 3, 4, 5, 6, 7, 8. 8 subsequences we have. So for a n length set, we have 2 raised to the power n subsequences. How does this theory actually comply? This is the corresponding hint that you need to keep with yourself and think about the problem. That first of all, think that how this formula comes into the picture, and then based on this formula, can we, like, based on the intuition of this formula, like how this formula comes up, can we somehow implement it in subsequences and get our answer? Now we know the basic criteria of thinking. Let's try to think in these terms, that how exactly 2 raised to power n comes up. So let's say if you have a set, how the formula comes as 2 raised to the power n, let's think about it. One way to prove is that this comes from the binomial coefficient, right? If you don't know about binomial coefficient, don't worry. But like, if you know, then let's say there are n elements. So I would say that some set of choices will be there where we will pick no element. So NC0 is the combination which calculates among n elements in how many ways you can pick 0 elements. Then in how many ways you can pick 1 element, how many ways you can pick 2 elements, and so on. At last, in how many ways you can pick n elements. The sum of this series is actually 2 raised to power n. And this is technically what we are doing, that in how many ways we can pick no element, in how many ways we can just pick 1 element. So in 3 ways you can pick 1 element, right? Just 1, just 2, just 3, and so on. So this also complies to 2 raised to power n. But there is a more intuitive solution for this. There is a more intuitive solution for this. Let's talk about that. Okay. Now you can carefully see that in every subsequent subset, whatever we write, right, you can see it correspondingly plays with the existence of elements and absence of elements. You can see in 2, 3, 2 and 3 are present, or 2 or 3 are picked, 1 is not picked. In 1, 3, 1 and 3 is picked, 2 is not picked. So what I'm trying to say is that for every element we have a choice, that we have to pick the element or not pick the element. Here also 2 choices, either we can pick the element or not pick the element. Here also we have 2 choices, we pick the element or not pick the element. Can I say that? Just think about it. Let's see the choices like this. If we picked 1, if we picked 3, and we do not pick 2, so we will be given the subsequence 1, 3, right? So I would say that if, let's say, pick represents 1 and not pick represents 0, then I can say something like this, that let's say none of them are picked, or just 3 is picked, or just 2 is picked, or just 1 is picked, or 1 or 3 is picked, 2 or 3 is picked, 1 or 2 is picked, or all 3 of them are picked. Then we will be getting our corresponding answers, right? None of them picked, empty. Just 3, just 2, just 1, 1, 3, 2, 3, 1, 2, 1, 2, 3, right? You can see this is a good strategy to think, right? That for every element we have 2 choices. If for every element we have 2 choices that we can pick or not pick, then we can apply all possible combination of these 2 choices. So if I have 2 choices for 1, then I have 2 choices for 2, then I have 2 choices for 3, and so on. Can I say if there are n elements, 2 into 2 into 2 into 2 becomes 2 raised to the power n if multiplied n times. Based on this intuition, can I say that the total number of possible subsequences will be 2 raised to the power n, right? You might be getting a feeling here that we are playing with bits. So don't worry, when we will come to the bit whenever we will discuss the bit manipulation part, then I will also show you that how you can form the subsequences subset, whatever it is, using bits, which will be an iterative solution, not a recursive solution. But for the time being, our agenda should be to just understand and absorb this, that the final total count is actually coming from this basic intuition that every element has two choices, that in my final answer I don't care about 2 3, I don't care about 2 3. In all my possible final answers, few of the answers will be there where I will pick and include myself, few of the answers will be there in which I will not include myself. If this intuition is clear to everyone, then we can move forward and try to solve the question of subsequences recursively based on this particular intuition. Now, based on the last situation, let's think about it. What can we actually do, right? We have a string like A, B, C. We have a string like A, B, C. I can say that if we want to find all possible subsequences of ABC, I don't know how to form all possible subsequences of ABC, right? But what I know that every element has two choices. Either we can include the element or we cannot include the element. So just think about it. This is a very big string, right? I know choices of A, B, C individually. Like I know some properties about individual elements. So if you can somehow break the problem so that it eventually becomes a individual character based problem, then I might be able to contribute, right? So I'll say that, okay, how about if somehow you get all possible subsequences of BC. So all possible subsequences of BC, let's write all possible subsequences of BC. All possible subsequence of BC. Now, what are all possible subsequences of BC? All possible subsequences of BC are BC, B, C, an empty string. Can I say that? These are all the possible subsequences of BC. And for the timing, just think that you got it. You somehow are able to generate it. You are somehow able to generate it. If we are somehow able to generate it, then technically what I can say is that in all of these subsequences, before we actually build the subsequence, we can apply the choice of A. We can apply the choice of A. What are the choices of A? The choices of A says that we can include A in one set of choices and we can exclude A or not pick A in one set of choices. Now we say that you wanted to go and bring BC, right? I'll say that, okay, go and calculate BC. Before you actually go and calculate BC, I'll say that with whatever set of combinations of BC you will get, once with every set of combination I will attach A and once I will not attach A. So if you attach A with every possible combination of BC, then you will get ABC, AB, AC, A. See? ABC, AB, AC, A. You are going to prepend, right? So with all possible combination of BC, I have attached A. And if I exclude A, that means I don't make any change. Whatever is going to be the subsequence of BC, I'll just keep it as it is. I can say that. Then in that case, it remains BC, B, C and empty. And can you see, we have got our 8 or 2 raised to the power 3 subsequences, right? And a similar strategy can be applied for BC. Now, technically, you don't even know anything for BC, right? You wanted to do for A. So I'll say that when you are actually going to contribute or when you are actually going to compute for BC, no? Before that computation, once I will attach A to everything and once I will exclude A to everything, and then you can do the computation, which will lead to an answer like this. But same thing you can say for BC, that I don't know how to calculate subsequence of BC. So if somehow you can give me all possible subsequence of C, right? What are all possible subsequences of C? All possible subsequences of C are C, an empty string. Can I say that? Now the same strategy we can apply here, that with all possible subsequences of C, I will play the game of B. What is the game for B? That I will once include B in all possible subsequences. Once I will exclude B in all possible subsequences. Now just think about it. If you include B with everything, this becomes BC and B plus empty is B. And if you exclude, then C comes as it is, empty comes as it is. So we are able to get all possible subsequences of BC. And technically, though, I don't even know for C. So finally, I'll say, just give me all possible subsequence of empty string. Now, what will be all possible subsequences of an empty string or an empty array? Now, when there is no data in the set, then 2 raised to the power 0 is what? 1, because the size of the set is 0, right? So 2 raised to the power 0 is 1. So if there are no elements at all, still you will be having one subsequence or one subset, that will be the empty one. So the empty string will be the only possible subsequence of empty. In every occurrence of this empty string, I will play the game of C. What is that? I will once include C and once I will exclude C. Can I say that? This is something that we are going to do. And this operation, see in which direction I'm going. I'm going from A to B to C. That, okay, I wanted to build the subsequences of ABC. I don't know. So you are going to give me all possible subsequences of BC, right? I am delegating my task to you that give me all possible subsequences of BC. But before that, whatever subsequences of BC you will create, in front of all of them, I will once attach A, I will once exclude A. I will not do anything. Then BC says that, like, whosoever gets this task, let's say some employee A got this task, they are going to delegate to someone else that you are going to bring me all the possible subsequences of C, right? So before you actually start creating, I am already declaring the fact that in front of all of those subsequences, once I will attach B and once I will not attach B, and so on and so on. This is a strategy that we can use, right? So let's think about it. So we say that let's write a function f that takes a string, and generally when we have strings or arrays, I take an index also, right? So that we can iterate over the strings or we can iterate over the array to get the possible combination, right? And because this is a printing strategy, for printing strategy, I have told you that you can keep an output. So what does this function says? This function computes all possible subsequences from index I to n minus 1 of the given string str in the output string output, right? So let's say we are going to write a function f of str. Why we need str? Because that's the original string. Comma I. Why do we need I? Because to iterate over the strings, we have seen the strategy that to eventually get all possible data of the string or characters of the string, we need some kind of an iterative variable. And we have this output in which we are going to possibly compute our things and actually print this output later. This is going to be the function that we want to create. And we will implement it recursively. Now, before we actually implement this function, let me show you what I am actually trying to denote with the function. Can I say this will be my original function call? We will say that I want to get all the possible subsequences from the 0th index to the last index, and whatever will be the subsequences will be stored inside output. So initially output is going to be empty. Now, I don't know how to get all possible subsequences of ABC, right? Because I don't know how to get all possible subsequences of ABC. What I will say is that go and compute all possible subsequences of BC. Now just think about it. If I convert this 0 to 1, then I'm going to get all the possible subsequences from first index to last index. So all possible subsequences of BC I am going to bring. But before we go there, in all of those subsequences, I will include A and I will exclude A. If you will include A, then I'm going to attach A in the output. And if you're going to exclude A, then the output string is going to be empty. Just think about it. Inside the output string, we have the final subsequences to be built. So same thing exists for A, this BC also, right? Then inside its output string, all final subsequences of BC will be there. But I am saying no, that with all of these subsequences, I will attach A in front of it. So I appended A. Now later when any character from BC will be appended, it will be appended after A, right? And same thing, all possible subsequences of BC will go there in the output string, and here we have not appended or not prepended anything. So in this function call, whatever subsequences are going to be built, they are going to be built inclusive of A. And in this function call, whatever subsequences are going to be built, they are going to be built exclusive of A. This is something extremely important that you need to understand and keep in your mind. I hope this point makes sense, right? And we have to technically just do this much part. Rest everything recursion will do itself. Now let's think about it. Now we don't know how to compute all possible subsequences of BC, right? So we will say that just go and compute all possible subsequences of C. Go and compute all possible subsequences of C. Same thing here. Go and compute all possible subsequences of C. All possible subsequences of C. What I am going to do is, I will once include B, I will once exclude B. And this is going to same happen here also, right? Because here also we are getting all possible subsequences of C. I will once include B, I will once exclude B. So include B, exclude B. And keep this thing in mind, they are not going parallel. We have already discussed that, or we should already know that recursion doesn't go actually parallel, right? They're going to complete one particular branch at one point of time. So now let's say if you want to include B, then can I say output will become AB? Why? Because we already included A, now we are also going to include B. This becomes AB. And here we want to exclude B, but we want to include A. So include A, exclude B. A remains as it is. So this output string remains as it is. Inside this output string, we appended B. Here, we are going to exclude A and include B. So just B will be there. Here nothing will be there because we neither want to we want to exclude A also and we want to exclude B also. This is what we will get. See how recursion is proceeding itself, and we are building up the answer inside the output string that I mentioned. So this printing strategy is actually coming up ahead, right? Now I don't know how to bring all possible subsequences of C. Somehow, somewhat, give me all possible subsequences of C. I will attach AB in front of it. Let's see. Okay. Here I will include C. I will exclude C. Include C, exclude C. Include C, exclude C. Include C, exclude C. If you include C, then you say that go and bring all possible subsequences of the empty string, because 3 to last index is what? Nothing. And in front of that, because you included A, you included B, and you are also including C, in front of it, I'm going to attach ABC. And here we will get AB. Why? Because this time we are not including C. So whatever are the elements we have included, only those elements will be included. C is going to be not included. And same thing I can apply here. Here you can see A include, B exclude, C include. A include, B exclude, C exclude. Here you can see A exclude, B include, C include. Here it is going to be just B, and at last ABC 3C, ABC 3 empty. And you can see now this is the base case. All of these are the base cases. How do we know the base case? Because now we have exhausted the string. Now we are technically in this part, we calculated all possible subsequences of empty string. Now this is the smallest sub problem or the most trivial problem for which we already know the answer, that if this given string is just an empty string, then the answer is just empty. So here we know that the subsequence is empty. I will attach ABC to it, AB to it, AC to it, and so on. This is how we are going to compute all possible subsequences. So if you see in this base case, inside my output string, every time I am having a subsequence, valid subsequence in the output. So how the calls will go? It will first go here, then it will go here, then it will go here, it will compute ABC. It will come back, it goes here, it computes AB. It comes back, it comes back. Then it goes to this, then it goes to this and computes AC. Comes back, goes here, computes A, comes back, comes back, comes back. Then it goes here, then it goes here, then it goes here, computes BC, comes back, goes to B, comes back, goes here, comes back, goes here, comes back, comes back, comes back. This is going to be the overall situation that is going to be there. So ordering of the calls, if I say precisely. So if I just cut this out, copy, paste. So let's change the color a bit. So you can say this will be the first call, second call, third, then this will come back fourth step, this will go here fifth step, comes back sixth, seventh, now goes here eighth, ninth, comes back 10th, goes here 11th, comes back 12th, comes back 13, 14, 15, 16, 17, comes back 18, goes again 19, comes back 20, 21, 22, 23, 24, 25, 26, 27, 28. So these are step numbers that I have written in order, in case you want to trace back on what particular steps you are actually going first and on what particular steps you are going later. This is something that I have traced back here, and this is how the recursion is actually going to work. I hope this much point is making sense to everyone. Now, based on this discussion, if we want to complete our recursive relation where we wrote a function f which gets a string I and output, then I can just directly say that. Let's assume, like, I don't know how this function will be implemented. So we will say that we will go and start computing all possible subsequences of from the I plus 1th character to the last character. But in one set of calls, I am going to append my ith character, and then in one set of calls, I am going to not append anything. So we will assume that the function f works correctly for this function call and the function f works correctly for this function call. So I will once call this, then I will call this. This will help us to compute function f for I, right? So we are going to assume function f works correctly for these two cases. And if that is the case, then we'll just call both of them one by one, and ordering doesn't matter. You can even call this first and this second, and that's how you will implement this. Base case, you can say that if I becomes equals to str.size, that is, you have exhausted all the characters, right? In that case, we can just print the output, because inside my output I have one valid string and I can return, right? So empty string is never going to prepare anything apart from empty, right? So whatever output you have computed, see, whatever output you have computed, I'm just going to attach empty string in front of it. It will remain as it is. So how about you just print it, right? So that's the printing that I'm doing, and return, and that's it. This is going to be the simple recursive relation that you can build in order to form subsequences, and everything is going to be done. Now let's try the coding implementation for this. I'm going to say that I'm going to write a function void f. It will take a string as a parameter. I can pass the string as reference because we are not doing any manipulation in the string. You can even keep it global if you want. Int I to denote which index we are at, and string output. This string we need to keep as a copy because we cannot keep this as a reference here, right? If you will keep as reference here, then it will keep on updating original string and we will get bizarre answer. So this will be passed by copy technically. And we say that if I becomes equals to str.size, we are going to print output in a new line and we are going to return. That's the base case. Otherwise, we will go and compute all possible subsequences of I plus 1 to n minus 1. In front of all of them, I'm going to once append I, and in front of all of them, I'm going to once prepend or append, whatever you say, nothing. And that's it. That's the implementation for subsequences. If you call f of, let's create a string abc 0, and the output will be an empty string. Output will be an empty string. If you run it, you can see we are getting all possible subsequences, and technically we are also printing this one, right? This is the one more extra line is getting printed due to the empty character, right? So if you will just shuffle the call like this, then you will realize that we are getting this empty character now above. So the ordering will just reverse, right? So now we are getting the empty character above. So any call you can make first, it doesn't matter. The overall answer is going to be same. And this is how we can print all possible subsequences of a given string. I hope this point makes sense.